Okay, good morning, everyone. Today we try our second text mining workflow. Please go to week 8 and download both files. So there is a workflow file and there's a text document file. So just as a recall, in the previous session, you might remember we used each word in a document. What I mean document could be either a sentence, maybe paragraphs, or whole bulk, whatever. So we divide our document to the constructing parts. Then we connect a dictionary. So we had a positive and negative dictionary. End up saying if a document has a positive or negative sentiment. So today we want to use machine learning instead of just connecting a dictionary. Then for today, each word could be a variable. If a word is existed in the document, the value is 1, otherwise 0. So basically, we convert a textual document to its equivalent numerics. But before doing that, look at these two sentences. So as you might know, one of the applications of text mining is just running through documents, then deciding if there is action is required. You can Google it. I think in Germany, they found a terrorist group by just checking emails. So basically, at least ethically and legally, there is no human reading people's email, but it might be some software that's checking if there is some threat, like a terrorist group. So what they do, basically, they read the text through some softwares, and in case there's some issues, they just notify agents, intelligent agents, to just look over there, and if there's any issue or any problem, somebody can make an action. Looking at these two documents, let's say we have two softwares that do text mining for us, and one of them is looking at the communications in Worcester Fire Department, and the one, Clark University. So look at these two paragraphs. Each has two almost sentences. So do you think the word of fire in the first one and second one has same value? So first one is like from Worcester Fire Department, and one, like, let's say tweets or emails or whatever from Clark University. Is there anyone said your file could be different in these two sets of documents or sets of? Yes. Why?
Because in the first, fire refers to general use that they are informed that we need. It's a mandatory need to use the word fire. While in second, it's fire is notifying that it's an emergency.
Exactly. So in the first one, fire it could be a general word. Almost everything could have a fire in it. In the second part, fire could be a threat. So you might make an action. So we as a human have our previous knowledge, and we know that hearing fire in the fire department documents may not be even important, but software companies or algorithms, they don't have the previous knowledge. How they do, basically, they look at the previous documents. If there is some words that are too common, they just disregard it because they think if there is a word that happens several times, almost every document, it could be just a general word that doesn't bring any new sentiments. So if it's the case, let's say maybe in Worcester Fire Department documents, you might see the word of fire maybe 50,000 times. Versus in Clark University, maybe if you look at the previous document, it just says 10 times. So if a word happens so many times before, it could be just a general document. The same word could have different sentiments based on the what's going on in the background. Okay, so also let's look at this sentence again. Worcester City needs to purchase 3 new fire trucks. So you might even drop subwords and like maybe numbers, and then we go to the roots of each word. For the needs is need. Trucks. The singular form is truck. So this is just so for in the text classification using machine learning, each word could be a variable. So, and as you see at the end of the table, I put 3 dots. It just means there is several other words. Having said that, under weather column, should I put 1 or 0? 0? 1? Yeah, weather is not existed, so 0. What about Clark? 0, right? So what about Booster? 1, because Booster is exists. Purchase 1, new 1, truck 1. What about good? City 1, fire 1, and for the remainder. So as you see, we converted a textual document to its equivalent numerics. So this 0, 1, 0, 0, 1, 1, whatever is numeric equivalent of the sentence that you see here. Now you can use machine learning algorithm to look over this specific sentiment of this document, because now we have something that we can input into our machine learning algorithms. Okay, so any questions so far? Great. Okay, so hopefully by now you could be able to download your KNIME workflow and open it. And even more interestingly, in image processing, you should understand the way how to convert a picture to equivalent 0 and 1s. Then the remaining just you can use machine learning algorithm and you can apply it. So for image processing, there's more steps. There's some filtering, whatever. So summarizing 0, 1s, but it's a little out of context for this class. But the big picture is you need to convert your images to some numerical equivalence. Then you can use machine learning algorithms to basically investigate your image documents. Okay, having said that, the first note is file reader. It's exactly the same as before. So I'm picking a CSV file from KNIME website, and those you can see is the exact same. So we have index ID, movie URL, a review about the movie, and a previous human classification. So somebody already look at those reviews and basically say either positive or negative. So the next steps is basically converting those texts to numerical equivalents, then using machine learning algorithm to predict. This time we don't use any dictionary. So first step is just converting this human-friendly format to something KNIME-friendly. You might remember in the previous classes, basically we make one single column that has all the information that is required. So click on document creation. So if you click this time, first part is title is optional. I empty string. It just basically label on your cells. You can just pick any column that you want. Previous one, we picked the URL column. So we wanted to, each cell has its URL. This time just left it as empty, but it may not be a good way of doing that. So I said the text is in the text column. And the only important part is a category column, which I say under sentiment. It's like positive, negative sentiments. And the remaining are optional. If you right click and look at table, so look at the last column, is document. It has the information of all other previous columns. But, and again, I said the label are empty in case you can still put URLs. But basically, this last column is just what KNIME can process it. KNIME cannot look at multiple columns for text mining processes. For us, it might be a little weird because why it just all of the information is just merged into one column. And since for KNIME, the only column that is needed, the last column, I just said, let's filter out the remaining columns and then just have the last column, which is enough good for KNIME to process our text. So if you like, you just have the last column. Okay, I give you a couple of minutes if you have questions or want to put some comments, then I go to the next one. Okay, let's look at the second meta node. So this is exactly like before. So we want to get rid of stop words, some word that happened too much. Like, for example, I just erase it, but let's say if fire might repeat this several times for the documents in the Boostify department. So maybe we can just easily get rid of. So as you see, the first one, we want to get rid of punctuations, then numbers, then words that are just have 3 characters or less. So basically, since punctuations, number filters, and words with a few characters may not bring that much of sentiment, we want to make it make our text mining easier. And just keep in mind, later on we consider each word as a variable. So if you can get rid of the words that doesn't bring that much of sentiments, you make your life much more easy. Also, stop words, we want to get rid of them, and then we want to convert all of them to the lowercase. And finally, we want to get to the roots. So, for example, if there's ing, it removes it. If they are in the plural format, you just make it to singular format, and so on and so forth. So by now, I have 2 columns. The first one is the first KNIME-friendly format, and the second one, after doing those, I think 5 or 6 preprocessing steps. Okay, so then we need to extract out those text. So in the next step, I want to just split each document with constructing words. So it happens to the back of the word. Look at this, before going to the back of the words creator, just right click on snowball stemmer. As you see, I have 2000 words, right? Sorry, 2000 rows. Look what happens after running back of the words creator. 155 case rows. What happens here, 9 just split each document based on its constructing words and just repeat them by itself. So in this case, if it's, let's say if a document has 20 words, now it just converted 20 rows. Might be a little strange, but it's the way that 9 works, and no worries. I mean, if you used to do text mining through Python or R, it might be a little strange, but it's just the way that 9 works. So there's no mathematics behind of that. So just how we need to convert textual documents to numerical equivalent in 9. So after each word, we have a bracket with term to a string node. We just remove that and convert each to a just string. So in the next few steps, I want to look at the frequency of each word in whole of my document and also in each document. So in whole of my body of documents and also in each document. So if you look at term frequency, I just want to say, look at that preprocessed document and find relative frequency of each document, each word within each document. So as you see, I mean, some of the words happened more than others in each document. Similarly, in the lower branch, I also want to look at overall frequency. So I'm just saying, let's just group by term as a string, which was this column. And I look at the table. So look, some words happen too much, like film, movie, time, watch. So this is some reviews from IMDb. So film is expected to be a general word. Like fire in like Worcester Fire Department documents. So maybe film doesn't bring that much of sentiment, because it could be just a common word, or movie, or time, watch. So maybe I can put a threshold and say, if my words happened more than this amount of time, just consider it as a general word. Let's just put 500, but maybe if you say, well, love couldn't be general, but anyway, so. So with row filter, I want to consider anything more than 500 could be just a general word. This could be very subjective, and you might everyone might have different number, but just in case, I just said let's consider 500 as a threshold. If something happened more than 500 times, it could be just a general word that doesn't bring that much of sentiment to my document.
Depends on the size of the document.
Yes, it depends on the size of document, but there is no biblical rule. It's very subjective. You might look at some documents online, some basically tutorials. They might have different ideas, so there is no strong or basic biblical rule for that. So yeah, you're very right. And finally, I just merged them together. So I got rid of the common words, and also I have their relative frequency within each document. Okay, I give you a few minutes in case you need to add some comments or you have questions. Then I go to the next one. So hopefully you remember how to make notes within workflow. Just right click and go to new workflow annotation, and you can put your comments here if it's needed. People over Zoom, if you have questions, you can also use your mic and ask your question if you have some. Okay, so let me just review. The big picture of this method is we want to do some pre-processing. First, we got rid of some words or part of the document doesn't mean that much of sentiments, such as words with a low number of characters, maybe numbers, stop words. And then we look at the frequency of each word in whole of documents. And then if the word happens too much or appear too much, it just means it could be just a general word that we want to get rid of. Okay, so what could be the next? Look at the output of pre-processing here. So far, we have the words that we want to work with, but we need to convert to numerical equivalent, right? So how you do that, look at document vector. I'm just saying that look at pre-processed document and make a vector. So this 0, 1 is called vector. This is a technical phrase for this 0, 1s. So when I say we look at the vector of our document, I just mean we look at its equivalent numeric, which is 0, 1s. So if you do that, just right click and look at outcome. It takes a little bit of time. So now look at the number of rows is 2000 because I had 2000 movie reviews. Now look at columns like hook, wish, touch, reality, think. So each word now is a column or a variable, and within and under those columns, I have equivalent 0, 1s. If a word happen in a document, you see 1, otherwise 0. For example, look at the first row 0, or you can call it vector, first vector. So it has hook, wish, touch. It has those first words, but then it doesn't have weak, it doesn't have passable, it doesn't have rows. So they are not existed in the first document, you see 0. Okay, so first, I have a column, which is a non-friendly column. It has all the information. In front of that, I have vector of words. So what else is remain? I also need to find human classification column, which was positive negatives. So I do it by category to class. I'm just saying that look at the document column and take out its classification column. Let's right click to category to class and look at the outcomes. Now in the last column, I have positive and negative labels or classification. So by now, I converted my document to its numerical equivalent or to its vector. And also I have a column that shows if that document or movie review is positive or negative. Everything is ready for general or regular machine learning project. So you have several numerical columns and you have a dependent column. You try to predict the dependent column with those numerical columns. Okay, so before starting our regular machine learning project, I give you like maybe 1 or 2 minutes in case you want to add comments or questions. Then I go to the next part. It really looks like 2 weeks ago when we had our first machine learning workflow. So you had some numerical columns that you try to use them to predict a dependent value. In case you are interested for image processing, I mean, I highly encourage you to go through that. It gives a good value to your resume. The only difficult part is the first part, how to convert an image to its equivalent numerical columns. It has several more steps, and maybe you need to do some summarization through some filters. But at the end, the overall workflow process is very similar to even text mining or regular machine learning project. Okay, next node is not even necessary. I just said label negatives with the red color, positive with the green. I just want to see if the number of positive and negative sentiments looks close to each other through just some visualization. It seems I have good amount of both classifications when I go through my observations. So maybe I don't need any resampling method. You might remember we had an example of Apple credit card, and I said when you one possible reason for the issue could be they don't have enough observations for female applicants. So when they wanted to train an algorithm to predict their credit, maybe they do much worse for the female applicants than many applicants. So if you have enough observation in both groups, you expect you have more balanced prediction accuracy. Later on, I also talk about some resampling algorithms in case sometimes you don't have enough observation in one group, how you can basically resolve the issue. Okay, so next module is partitioning. I just said let's just dedicate 70% to train, 30% to test. So what it does, it just look at 70% of your observations and learn how to predict the dependent variable, which was positive and negatives. Then it tests its accuracy over the remaining 30%. As you see, the upper branch after partitioning, 70% of data goes to decision tree learner, and in the lower branch, 30% goes to decision tree predictor. In the learner part, you just need to identify your dependent variable or class column, which here means dependent variable, some internal tuning or settings of decision tree. Here, you can just leave it as default, but you can play with the number of threads, number of records per node, number of records per, to a store for view. So these are something internal of decision trees. If you don't have previous knowledge of a decision tree, that's totally fine. Just leave it as default. But they might have significant effect on the accuracy of your model. And same for decision tree predictor, just leave as default. So here we just train and test our model, then we need to look at its accuracy. So here I have two classes of positive and negative. I want to have a good accuracy rate in both groups. You might talk about sensitivity and specificity. So if you want to have a balanced prediction, you should have both high sensitivity and specificity. They just show your accuracy on each group. Besides sensitivity or specificity, you can also look at ROC. Details of ROC a little out of context for this class, but basically, when you have two class classification, like here, when you have positive and negative, or female or male, or die or survive, so two class classifications, if you have high ROC, it just means you are good in both classes. So you don't have to check sensitivity and specificity separately. High ROC just means you are good in both. But it doesn't hurt if you check sensitivity and specificity for both groups. If I click on a scorer, I just said first class is actual, second one is what I predicted. And we look at accuracy. So accuracy is 91%, pretty high. Also, you have sensitivity and specificity, both about 91%. That's pretty good too. And let's check our ROC or error under the curve, 94.2. Very good accuracy, sensitivity, specificity, and also ROC. It just means you have a very good model. For some basically domains, maybe 91 is not good. I'm just saying generally speaking. So you might work in some industries which 95 is a good number. Or some mostly human related topics has a lower accuracy rate, maybe 70, 80. In more industrial applications, even more than, we usually look at more than 90% as accuracy. Right. Any questions about this workflow? I think it should look straightforward. So what could be the next? So we also have more workflows. I'm bring some more examples. So in next challenges, we want to look at some projects that you don't have balanced observations. In some groups, you have more observations and how you can deal with that. If it's the case in your project, you can Google it. It's not difficult. Basically, You just need to drag and drop some nodes that resample your models, sorry, your observations. And then also the next one could be cross-validations. So here we just have one train, one test. What happens if you have several trains and several tests with same data set? So let me show you on the board. So I'm just going back to the previous example. Let's say this is your pool of applicants, previous one. And as you see, let's say it seems 80% of previous applicants were men and maybe 20% females or women. So in this case, you might expect you won't have a great model for the female applicants. There is some methods that we review later on. One, it just makes some new observations. So basically you synthesize new observations. So there's some algorithms that maybe you raise number of applicants. So maybe here double it. And then the new part is just basically there's some algorithms that look over your current observation and just make some random new ones. The second types of methods, you just repeat them. So maybe it just randomly picks some observations and just repeat them here. But the goal is to have more observation in both groups. So you hope to have a more balanced model. The second challenge that you want to go through is class classification. So let's say this is the pool of my observations. For 5 class classification, I divide it to 5 groups. Fully 1, 2, 3. In the first round, I consider 1, 2, 3, 4 as my train section and 5 for my test. So let's say each slice has 20%, so 80 versus 20. Then in the next round, maybe I consider 5, 2, 3, 4 for training and slice 1 for testing. And just repeated all the cases. So 5, 1, 4, 3, 2. So now I have 5 sets of train and test, and I just look at the accuracy on ROC in each cross-validation. So let's say this, here I have accuracy, In the first cross validation, let's say it's like 90%, second one 80, then 60, then 95, then 99. What would you say if there's the accuracy of your cross validation? I'm not sure this part can see that, but first cross validation 90%, then 80, 60, 95, 90. Do you see the high variability or variance? So it just changed 90%, 99, 60%. So it seems you don't have a reliable model. Because if in the same data set, you picked 5 random train tests, in one experiment was 99% accuracy, then in one of them was 60%. It's just evidence you don't have a good model. So even with your current data set, you don't have that much reliable accuracy. You want to trust this model to use it for future prediction. Because in the future, you don't know, could be 60%, 90%, what? So you cannot rely on this model. So it's one of the things I evaluate your final project. So I look at your cross validation outcomes, and you need to talk about that. So let's say even you have high accuracy in all of the folds, you should say you have a reliable model because it's each fold you have high accuracy. If you don't have, if you have such a case, which there's a high variance in your outcomes, still you need to talk about that. If you can improve, that's okay. If you cannot improve it, that's fine too. So, but at least you need to justify that. You need to say what happened when you did cross validation, and it seems you don't have a reliable model to trust based on. So just keep in mind, some of you lose some credits in the final project because they never talk about their results. And again, you don't have to have high accuracy, or you don't have to have a high reliability, but you need to talk about your results. The best case scenario, you expect to have high accuracy in each cross validation. But if you cannot, what can you do? So that should be fine. Any questions? Okay, so let's just stop for today. Today I didn't want to teach too much. And let's just stop share and go to the attendance. Okay, the last link is your class attendance. That's me.